Okay, Nerst distribution law. It states that a solute will distribute itself between two immiscible solvents in such a way that the ratio of concentration of solute at equilibrium is constant at particular temperature. It states that a solute will distribute itself between two immiscible solvents in such a way that the ratio of the concentration of solute at equilibrium is constant at particular temperature. When a solute A distributes itself between the two immiscible solvents, phase 1, aqueous phase, and phase 2, organic phase at equilibrium, the ratio of concentration of solute in phase 1, aqueous phase remains constant at particular temperature, which is called distribution coefficient or partition coefficient. If A1, the concentration of solute in phase 1, and A2, the concentration of solute in phase 2, then equilibrium KD equal A2 over A1, KD distribution coefficient or partition coefficient. Application of distribution law, solvent extraction. The process of separation of solute from a solvent by other immiscible solvent is known as solvent extraction. The process is used for the separation of organic substance from aqueous solution. The aqueous solution is second with an immiscible organic solvent such as ether, benzene, chloroform, or carbon tetrachloride in separating point. Determination of solubility. It is applicable for the determination of solubility of the solute in one of the solvent if the solubility in another solvent and distribution constant, that is Kd equal to SO over Q, solubility of A in organic solvent over solubility of A in aqueous solvent. Desilverization of lead Park's process of parting process when molten zinc is added to molten lead containing silver, argentiferous lead, zinc, and lead form two immiscible layers, and silver is distributed between the two layers. Since the distribution ratio is about 300 in favor of zinc at 800 degrees Celsius, most of the silver transfer into the zinc layer. On cooling zinc layer, an alloy of the silver zinc is suppressed. The silver zinc alloy is distilled in a retort when zinc passes over, leaving silver behind. When log value of concentration of a solute in two solvents are plotted, then we get slope equal to 1 over n. By knowing the value of n, we can determine the molecular complexity of the solute in solvent. If n equal to 2, the solute exists in the dimer in the region of the solvent. If n equal to 3, then the solute exists in the trimer, so on. Distribution is also law is used in partition chromatography. Limitation of distribution law, the temperature remains constant throughout of the experiment. Two solvents should be immiscible or partially miscible. The solute should be present in the small amount. The solute should behave ideally, that is, it should not dissociate or associate in the solvent. Okay, it's all about Nerst distribution law and application and limitation. Thanks for watching, and request you all like, comment, share, and subscribe. Thank you for patience. That's now bye-bye. See you again.